Now that we've talked about require, I want to talk about asserts. And assert, the function assert, is used to check invariants. And invariants are states that our contract or variable should actually never reach, like never ever. And for example, if we decrease a value, then it should never get bigger. It should only get smaller. And that's an obvious example. And I want to use that in our smart contract now because it is a nice showcase. So what I'm going to change in our smart contract is, instead of an unsigned integer 256, which is a fairly large numbers range, I will use an unsigned integer 8. And that is not so uncommon that you're going to limit the unsigned integer range, because it is for guess optimizations. So if you do guess optimizations, you're trying to make variable types small enough that they can fit in the same storage slots. It's a different technique. It's something that I do not want to go in depth right now. Just bear with me. Now we have introduced a potential bug over here. We are going to fix the error messages in a second. But the bug is our unsigned integer 8 ranges from 0 to 255. So we're going to convert this over to unsigned integer 8, because that's an unsigned integer 256 by default. And this one is an unsigned integer. Let's just make this an unsigned integer 8. Now, the problem is that this value over here can roll over in solidity 070. And one thing that we should never reach is that the balance received, even though we add something, should be smaller, is again smaller than, well, what we added. So essentially, the unsigned integer 8 of message value should always be the same as message value. But let me show you what I mean by that. So if we are going to deploy this smart contract, and we are going to send 257 way to this smart contract, so receive money, then let's check the balance. Let's see how much is actually in the balance received. Oh, it is only 1. And why is that? The reason is that it will roll over to 0. So it can store 0 to 255. If you try to put in 257, then the value 256 becomes 0. And the value 257 becomes 1. And then it's only stored 1. So if you try to withdraw again, you cannot withdraw, well, more than your balance. Or you introduce some weird bugs in your smart contract. So one thing to test that and to make sure that this can never happen, or this should never happen, is to use assert statements. And assert very much functions the same as require. So you input, you have an assert function, and you compare something. And if it evaluates to false, it will stop the execution of the smart contract, and it will roll back everything. So in this case, we can assert that our message value is the same as the unsigned integer 8 of our message value. And let's see what happens now. So I'm going to deploy the smart contract, and I'm going to try to deposit 256 way. And it's going to stop the execution. And the difference to the require is that this is going internally to a panic opcode. And what panic means is that it's going to use up all the available gas. So we provided 300,000 gas. It's going to use up 300,000 gas. It cannot throw an exception, a normal one. It is just stopping the execution, eating up everything it had, saying this is a panic. We stop here. Yeah, essentially it is a state that your smart contract anyway should never reach, because in this case a balance can only get bigger and smaller, and it will just make sure that, well, we shouldn't execute this particular transaction again, because it's something that shouldn't happen in your smart contract.